Hello viewer and welcome to the e-learning classroom. So today we want to look at KCSE 2023 paper 2, that is the physics paper 2 marking scheme. So let's go straight to section A, which carries 25 marks. So question 1, state with a reason the effect of reducing the heater current on the X-rays produced in an X-ray tube. State with a reason the effect of reducing the heater current on the X-rays produced in an X-ray tube. So reducing the heater current reduces the number of electrons emitted from the cathode, hence reducing the intensity of the X-rays. Also, you can say, hence reducing the number of X-rays produced. So the heater current affects the intensity by affecting the number of electrons dislodged from the cathode. Question 2. State one property of a magnet. So magnets have very many characteristics of properties, but we'll sample some of them. Number 1. When a magnet is broken into two or more pieces, the pieces retain their magnetism, each having a north pole and a south pole. Number 2. A freely suspended magnet rests facing the north-south direction. The next property, a magnet has two poles of equal strength. All magnets have magnetic fields. It's another property. Like poles of magnets repel, while unlike poles attracts. A magnet has the ability to attract pieces of magnetic materials brought near it. A magnet loses its magnetism when heated or when hammered in north-south direction. Those are some of the properties of magnets. Let's go to question 3. State the importance of using the correct color codes in the domestic wiring system. Importance of using the correct color codes. So number 1, correct color codes help differentiate between the live, neutral, and hard wires. Correct color codes helps one to do correct connections, e.g. The correct connections of switches and also the fuses, and also helps you to do correct wiring. So the next point, correct color codes enhances the safety of the electrical users from the danger of electric shocks. That is the importance of using the correct color codes. Let's go to question 4. Using the energy band theory, explain the difference between conductors and semiconductors. Using the energy band theory, explain the difference between conductors and semiconductors. So number 1, in conductors, the conduction and valence bands overlap, while in semiconductors, they do not overlap. Number 2, conductors have no energy gap, while semiconductors have a relatively small energy gap between the valence band and conduction band. Number 3, increase in temperature increases the electrical conductivity of semiconductors, while increase in temperature decreases the electrical conductivity of the semiconductors, or of the conductors, sorry. So we have increase in temperature increasing electrical conductivity of semiconductors, and at the same time increase in temperature decreases electrical conductivity of conductors. Maybe to expound on that point is that when you increase temperature for semiconductors, electrons in the valence band are able to traverse through the energy gap to the conduction band, so it becomes a better conductor. But for the conductors, when you increase temperature, the atoms gain kinetic energy and start vibrating more, and therefore they disrupt the path of the free electrons. That's why the resistance increases. So let's go to the fourth difference. Semiconductors have almost empty conduction band and almost filled valence band, while conductors have almost filled conduction band and almost empty valence band. The last difference, electric current is conducted through flow of free electrons in a conductor, while in a semiconductor, electric current flows through both free electrons and positive holes. Question 5. State one quantity that must be kept constant for Ohm's law to hold. One property or one quantity that must be kept constant for Ohm's law to hold. So number one is temperature. Number two is the length of the conductor, and also the thickness of the conductor. Let's go to question 6. Before question 6, also it's important to know that the length of the conductor and the thickness of the conductor are affecting resistance, because we know for Ohm's law we relate voltage and current. So resistance is held constant through having uniform length of a conductor and also uniform thickness of a conductor. Figure 1 shows an object placed near the eye of a long-sighted person. The figure 1 shows an object placed near the eye of a long-sighted person. So you can see near object. Then complete the diagram to show where the image is formed. So because this person is long-sighted, that means they cannot see an object which is near. So that means the rays from the object pass through the eye lens and then they converge beyond the retina. So that means you cannot be able to see that object. Question 7. Figure 2 shows an object using Figure 2 shows a student using a small plane mirror to view her image. Explain why the student is able to see her face and not her legs in the mirror. So you can see the face relative to the mirror, and of course also the legs relative to the mirror. So you are told why the student is seeing the face and not the legs. So the face falls within the field of view of the plane mirror, while the legs are outside the field of the mirror, hence the student cannot see them. Remember, this is a plane mirror. If it was maybe a convex mirror, you could be able to see the legs. But of course now this one is a plane mirror. That means the field of view cannot accommodate the legs. Let's go to question 8. Figure 3 shows a coil made from tungsten being used to heat some water in a beaker at a constant voltage. Figure 3 shows a coil made from tungsten being used to heat some water in a beaker at a constant voltage. State 2 ways in which the coil can be improved so that the water boils in a shorter time. 2 improvements to make the water boil in a shorter time. So number 1, by increasing the number of turns of coils per unit length. Increasing the number of turns of coil per unit length by using coils made from a thinner wire. Remember, thinner wire has a higher resistance. That means it will produce more heat. Number 9, describe how a cathode ray oscilloscope may be used to measure the voltage of an alternating signal. Describe how a cathode ray oscilloscope may be used to measure the voltage of an alternating signal. Time base is switched off. X plates are earthed. That means the X plates are at zero potential. Then AC signal is connected to the Y plates. The displacement of the spot on the screen from the middle. Remember, the AC will be moving both up and down. From the middle is measured, and then the voltage is calculated using the formula. Voltage is displacement times sensitivity. That is the number of divisions times voltage per division. So let's go to question 10. Explain why it is not advisable to leave a lead acid accumulator in the discharged condition for a long time. Explain why it is not advisable to leave a lead acid accumulator in the discharged condition for a long time. This is because sulfation can take place whereby the lead 2 sulfate metal hardens up and cannot be reverted back to lead metal and lead 2 oxide metal through recharging. So the keyword is sulfation, hardening up of lead 2 sulfate, such that when you try to recharge the battery, the lead 2 sulfate metal cannot revert back to lead and lead oxide metals. Question 11. State two properties that distinguish electromagnetic waves from mechanical waves. Two properties that distinguish electromagnetic waves from mechanical waves. So the first difference, electromagnetic waves do not require a material medium. The key one is material medium for propagation, while mechanical waves require a material medium for propagation. All electromagnetic waves are transverse in nature, while mechanical waves can either be transverse or longitudinal in nature. These are the two differences. Let's go to question 12. Thorium element decayed to produce gamma radiation as shown in the equation below. So we have thorium, then we have thorium plus gamma. State the values of A and B. So when an element undergoes gamma decay, definitely you realize that both the mass number and the atomic numbers do not change. That means A is still 230, B is still 90. Let's go to question 13. A student observed a rainbow when it was raining and the sun was shining. A student observed a rainbow when it was raining and the sun was shining. Explain how dispersion of white light by raindrops leads to the formation of the rainbow. A rainbow is formed when the light from the sun is reflected, as you can see from the diagram, dispersed, and totally internally reflected by raindrops. So as you can see from the diagram we have there, that is a reflection and dispersion, then you have total internal reflection, then we have further refraction, and what's coming out is a rainbow. Let's go to question 14. State the reason why sound waves get refracted away from the ground on a hot day. State the reason why sound waves get refracted away from the ground. In other words, why can't you hear sound from far during a hot day? During the day, air close to the ground is warmer than air above the ground. The sound wavefronts therefore travel faster near the ground than above the ground, hence causing the reflection of the sound away from the ground. In other words, because air close to the ground is warmer than above, sound near the ground moves faster than above. Therefore, the sound will be reflected up. In other words, it disappears into the sky. So that is section A. Let's now go to section B, which carries 55 marks. So question 15. Remember, in section B you are supposed to answer all the questions. So question 15. Figure 4 shows a God-leaf electroscope. You can see the diagram. We have B, C, and A. Identify the part labeled A. Is Harding, that's the name of part A. Roman 2, state the function of the parts labeled B. The function of part B. So, which is an insulator, of course, the insulating plug, PLUG. So, it prevents the charges given to the cap from leaking away through the casing. So, in other words, that part B, which is a insulating plug, it helps to minimize or to prevent charges from the cap from leaking through it to the metal case. A function of part C, which is a leaf, can either be made of gold or aluminum. That's a leaf. So it indicates the presence of charges when it diverges due to repulsion with the metal plate, or the absence of the charges when it falls completely. So that is the function that indicates the presence of charge when it diverges due to uh, repulsion. A highly negatively charged rod is slowly brought close to a lightly charged gold leaf electroscope. The keyword is highly charged rod and lightly positive gold leaf. State what is observed on the screen or on the gold leaf. State what is observed on the gold leaf. So the gold leaf falls and then rises. Explain the observation made in B Roman 1. The negatively charged rod repels some electrons from the cup to the leaf and plate, which neutralizes the charges there, hence the leaf falls. Since the charged rod is highly negatively charged, more electrons are repelled to the leaf and metal plate, which makes them repel each other, hence the gold leaf diverges. So we are saying now the negative rod repels some electrons to the leaf and plate, which neutralize the already existing charges there, and then the leaf falls. And then of course, because it's highly negative, so it will repel more electrons, which will now go to the leaf and plate, and then they repel there, and of course the leaf now rises or diverges. Let's go to question C. Figure 5 shows a thin wire connected to a highly positively charged rod and placed close to a candle frame. So we have a thin wire, as you can see there, highly positively charged rod, as you can see there on the flame. State what is observed on the flame when the wire is brought closer. So when the wire is brought closer, of course the flame will blow away from the wire. Explain the observation for the reason for the observation in C. Due to the high concentration of positive charges around the sharp pointed part of the wire, the air around the wire gets ionized, and then positive air ions are repelled in form of electric wind, which blows the candle frame. The negative air ions are attracted to the wire, hence neutralizing the positive charges on the wire. So definitely we know this is a point action. That is the name of this process, whereby now we are saying that due to the high concentration of positive charges along the wire, the sharp pointed part of the wire, the air around it will be ionized such that positive air ions now are repelled in form of electric wind that is blowing away the flame. Of course, now the remaining negative air ions are attracted, which neutralize the charges on the wire. Let's go straight to question D. So figure 6 shows an arrangement of 3 capacitors in a circuit. Determine the effective capacitance of the arrangement, effective or total. So we start with the 2 and 6. They're in parallel, so we add directly 2 plus 6, 8 microfarad. Then 2 and 6 combined, meaning we are taking it as one capacitor of 8 microfarad. Then that one 8 plus the other 8, which are in series now. So in series, product of a sum. So 8 times 8 over 8 plus 8, which is 4 microfarad. That gives you the total capacitance. Question 16. State Fleming's left-hand rule. State Fleming's left-hand rule. It says that if the left hand is held with the thumb, first and second fingers mutually at right angles, so that the first finger points in the direction of magnetic field, second finger in the direction of the current, then the thumb points in the direction of motion. I repeat, it states that if the left hand is held with the thumb, the first finger and the second fingers mutually at the right angles, so that the first finger points in the direction of the magnetic field, second finger in the direction of the current, then the thumb points in the direction of motion. Let's go to B. Figure 7 shows an electric motor with a coil ABCD in the magnetic field. So you can see coil ABCD, and of course you have a source of current, that is a cell connected to the coils. Indicate with an arrow indicate with an arrow on the coil ABCD the direction of the current high when the switch S is closed. When switch S is closed, direction of the current. So you know current will start from positive terminal through variable resistor, through D, through C, through B, through A, back to the negative terminal. So you just require to indicate with an arrow on the diagram on the wire. State the direction in which the coil rotates when the switch is closed. So the coil rotates in clockwise direction. Explain what makes the coil to rotate. Due to the interaction between magnetic fields between the two magnets and the coil ABCD. When current flows through the coils, magnetism is induced through the electromagnetic induction, which in turn interacts with the magnetic field between the two magnets, hence causing the coil to rotate in the clockwise direction. So for that case, again, you remember you are using the Fleming's left-hand rule to determine the direction of the motion, because you already have current and magnetic field. So when you have current and magnetic field, you use the left-hand rule. When you have motion and magnetic field, you use the right-hand rule to determine current. But for this case, we're determining motion, so we use the left-hand rule. So let's go to the next question, Roman 4. State the 3 ways in which the power of this motor can be increased. 1. Increasing or by using a higher number of cells, that is increasing the current in the coil. Using a stronger magnetic field or using stronger magnets. Increasing the number of coils per unit length. Those are the 3 steps you can take to increase the power of the motor. State the purpose of the rheostat in the setup. It regulates the amount of current passing through the coils. That is the importance. Regulates the amount of current passing through the coils. Question 17a. Figure 8 shows a setup that may be used to investigate photoelectric effect. Figure 8 shows a setup that may be used to investigate photoelectric effect. In the setup, a UV source is placed close to the window. So you can see a vacuum there, battery, switch. You have A, which is the cathode, B, which is the anode. You can see the galvanometer and the switch, and also a window which can be opened. Explain what is observed on the galvanometer when the window is opened and the switch is closed. Switch closed, window opened. So the galvanometer deflects, indicating some flow of current. The UV radiation strikes the cathode and electrons are emitted through photoelectric emission. These electrons are repelled by the cathode and attracted by the anode, hence completing the circuit, and the current flows. That is the observation and what it means. Explain why parts A and B are placed in a vacuum. So that is to prevent loss of kinetic energy of the photoelectrons due to collisions with the air molecules, which may make them not reach the anode. To prevent loss of kinetic energy of the photoelectrons due to collisions with air molecules, which may make them not reach the anode. That is a direct like that. Number B, a photon of red light has a wavelength of 8.0 10 power 1 meter. Determine the energy it contains. So you have wavelength, you are trying to find energy. Planck's constant we are given 6.63 10 raised to negative 4 joules second, and the speed of light c 3.0 10 power 8 meters per second. So if you have wavelength, Planck's constant, and speed, how do we get energy? So energy is hc over lambda, that comes from hf, where f is c over lambda. So energy is hc over lambda plus constant times the speed of light all over the wavelength, and the answer is 2.46 times 10 raised to negative 25 joule. Let's go to number C. A metal surface has a work function of 4.5 electron volt. A metal surface has a work function of 4.5 electron volt. Planck's constant H is 6.63 times 10 raised to negative 34 joules second, and the electronic charge E is 1.6 times 10 raised to negative 19 coulomb. Determine the work function of the metal in joules, converting electron volt to joules. So you simply multiply by 1.6 10 raised to negative 19, which is a change of an electron. So when you multiply 4.5 electron volt by 1.6 10 raised to negative 19, you get 7.2 times 10 raised to negative 19 joule. Maximum wavelength of a radiation that will cause electrons to be emitted from the metal surface. Maximum wavelength, that means through the work function. So work function is hc over lambda maximum, hc over lambda maximum, because work function is also hf naught, where f naught is the threshold frequency, but when you replace the threshold frequency with the speed and wavelength, it becomes c over lambda maximum. So when you solve that, you have the work function 7.2 10 raised to negative 19, Planck's constant 6.63 10 raised to negative 34, speed of light 3.010 power 8. So the maximum wavelength becomes 2.7625 times 10 raised to negative 19 times 10 raised to negative 7 meter. Question 18. A. Figure 9 shows the image produced by a concave mirror of focal length 20 centimeters. The focal length is 20 centimeters. So question 18. A. Figure 9 shows the image produced by a concave mirror of focal length 20 centimeters. So you can see the image, you can see the focal length, which is 20 centimeters, and the center of curvature, and also the concave mirror. Roman 1. On the same diagram, draw rays to show the position of the object, location of the object. So the first thing, if you're not able to draw directly, you can first sketch somewhere a rough position of the object, and then you can be able to see how the rays propagate from the object. So but if you are thorough, you can go a ray through C. That one has 2 arrows. There's a ray passing through center of curvature, 2 arrows. Then we have a ray through focal length that was parallel. A ray through focal length must have been parallel, so parallel focal length. But of course we are working on the reverse, but the directions must remain. You can also decide to pick a ray through the pole, whereby the angle of incidence will be equal to the angle of reflection. So any two sets of rays will give you the object, and the object is real in this case, but the directions are very, very important from the object towards the image. So given that the diagram is drawn to scale, determine the distance of the object from the mirror. So we are told this diagram is drawn to scale, and we also told that focal length is 20 centimeters, which has already 2 squares. So that means the object distance will be, that is you count the number of squares, that is 21, 22, 23, 23. Of course each small square is 2 centimeters, so that is 26 centimeters. That is 26 centimeters, because each small square, if you look at 10 small squares are representing 5 small squares are representing 10 centimeters. That means this one will be 26 will be 26 centimeters. Then we have magnification, V over U. So V, we have 80 squares, that is 80, divided by 26, the answer in Roman 1, which will give you 0.077 as the magnification. That's a ratio, so it has no unit. You can also decide to take HI over HO, which will still give you the same answer. Let's go to part B. Figure 10 shows a ray of light incident at the pole of a convex mirror. Remember, a ray at the pole, angle of incidence is equal to the angle of refraction. So that means you're trying to complete the diagram to show how the ray may be used to locate the image formed by the mirror. So definitely we know that the angle of incidence is equal to the angle of reflection, and then we have been able to see that with the direction. State any two characteristics of the images formed. Images formed by convex mirror, they are always virtual, erect, and diminished. So those are the properties, they are always like that. Question 19. A cliff obstructs an observer from seeing an approaching car. A cliff obstructs an observer from seeing an approaching car. Explain how the sound from the car reaches the observer before the car emerges. Light and sound difference. So light only moves in a straight line, hence the light rays from the car are obstructed by the cliff, while sound travels in all directions, hence the sound from the car deflects around the cliff and the observer hears the sound without even seeing the car. That is a difference. Sound can only move in a straight line, so it's blocked by the cliff. But of course, sound will be able to maneuver because sound moves in all directions and it can diffract along the cliffs. Figure 11 shows a displacement time graph for a certain wave motion. Determine the period. So we have the black one. So period is crest to crest, which is 0.4. You can also pick trough to trough, 0.6 minus 0.2, which is still 0.4 seconds. That is the period time for one wave. Frequency. So frequency is 1 over period, so 1 over 0.4, which is 2.5 hertz. On the axis, draw a wave whose frequency is twice the one obtained in part 2. So when frequency is twice, it means time taken for one wave is half. So if this one is taking period is 0.4, the other one, the period will be 0.2. So crest to crest 0.2, crest to crest 0.4, crest to crest 0.6, because we are simply saying where the initial is covering one wave, sorry, from 0 to 0.4, the other one is covering two waves from 0 to 0.04. That means crest is covering half of the other crest, which was 0.4. So this one is covering 0.2, 0.2, 0.2. The other one is 0.4, 0.4, 0.4. That's how we draw that. State the meaning of the term refraction. Refraction refers to the bending of waves when they move away from one medium to another, or when the medium propagation density changes. So that means reflection is bending of waves when they change a medium, well, of course on the same medium, but of course when the density of the medium changes. The last part, figure 12 shows a rectangular glass block dipped in a ripple tank in which plain water waves are generated. So this glass block is under the water in a ripple tank, so the water is above. That definitely tells you that the water above the glass block is shallower than the water where there is no glass block, because when the glass block is under the water, it will make that point shallower, and we know when a point is shallower, definitely the speed will reduce. That means wavelengths will reduce, the wavelengths will reduce. Complete the diagram to show how the water waves moves in the region that has the glass block. So you can see that is towards the normal, and again the wavelengths have reduced and also have bended towards the normal. Once you draw the wavefront, that is the dotted line with an arrow, then you draw the waves perpendicular to the wavefront. but of course now you must also ensure that you know whether the wavelength has increased or decreased. So that marks the end of that paper, that is KCSE 2023 paper 2, which had 19 questions and 8 marks. So you can check the concepts that have been highlighted here and also see how you can perfect on them as you prepare for the forthcoming exam. So, and also it's important to look at the concepts, how they are being tested. The paper was standard, but as well some questions are seemingly simple, although they require some technical approach. So it's important as a student you consider the concepts that are being tested and how you answer them. So that marks the end of today's session. Remember to give us feedback through the comment section, or maybe you can make some inquiry. And also don't forget to subscribe to our channel and also to stay tuned for further interactions. I wish you all the best.